of the parabola. You can also plot points, and just for grins, if you have a graphing calculator, which some of y'all do, I'm going to show you. So we type in y equals 2. What was the problem again? It was, can someone read me the problem? What was it?
3x squared minus 12x plus 8.
3x squared
Minus 12x.
Minus 12x plus 8.
Plus 8, right.
Thank you. And I'm going to graph that. What did I do? I forgot the x. Okay, so there's my graph right there. We want to find the vertex. We could go second and trace. And we know that that's going to be a minimum because it's the bottom of the graph. So pick minimum. It'll ask you for a left bound. And you can see that your flasher is on the left of the vertex already. So you just hit enter. Then it'll ask you for a right bound. So you scroll to the right of the vertex, anywhere to the right of the vertex, hit enter again. And then I'll say guess, but I don't think mathematicians don't usually guess. I'm not even sure why that feature is on the calculator. So I hit enter again.
It's to narrow down where to find a vertex, because you can find multiple vertices, and so it's just the way the computer processes it. Basically, you have to do like a left bound, right bound, and then you guess somewhere in the middle so it knows which vertex you're talking about.
Well, there's only one vertex though. Oh, you mean
yeah, but you can find multiple ones.
Oh, gotcha.
Yeah.
I always thought, why did they put that on there? Okay, so notice that, I don't know how well you can read this. It says 1.99999999. The pixels on these things sometimes are a little bit off. So if you get that, that's the same as a 2. If you actually looked at the table, if you go second and table, you can see that the vertex, can y'all see that the vertex is actually at 2, -4. So, and that can give you points to graph as well. So if you have a graphing calculator, it's very, very handy on these types of problems. And if you want me to spend more time showing you how to use your calculator, I'll be happy to do that during office hours.
You can also evaluate functions at certain values. So when you find your
Absolutely, you can do all kinds of stuff.
Yeah.
So I wish everyone had one because they're awesome. Okay, so get this back to where we hit. All right, so the second one though is super nice because they've given it to us already in vertex form, so we don't have to do any manipulation at all. We know the vertex is going to be HK, where this is my H and this is my K. So the vertex is going to be 3 because we always take the opposite of what's on the inside of the parentheses. And the Y coordinate will be 5. So 3, 1, 2, 3, 4, 5. That's my vertex. This tells me it's going to open going downward. So I know it's going to be like this because it's negative. Now, again, if we look at our X and Y squareds, and again, I'm going to pick -1, 0, and 1. I mean, -1, not -0. -1, 0, and 1, and square those. So if you square -1, that becomes 1, and multiply it by -2, that becomes -2, and then this stays 0. And then 1 squared times -2 is also -2. So from this vertex, we're going to go left 1 and down 2. and then right 1 and down 2. So that's what these tell us to do. And there's our graph right there. Okay. So so on the homework, and I'm gonna pull this up, we're going to divide into groups and do the first few together, and then we'll do the last 4. I mean, we're going to do the first however many in groups. I think it is like 14 problems, and then we'll do the last 4 together. And these are going to be the groups that what you're going to do. Group 1. So if you'll write this down, because I'm not sure what group you're going to be in. And if you forget, I'll tell you when we bop in. But group 1 is going to be doing 7, 9, 21, and 23. Group 2 will be doing the next 51, 53, 57, 61, and 67. And group 3, 73, 75, 83, 85, and 91. Everyone in a group should be able to do at least one of the problems. So if one person wants to do 2, that's okay. But every single person in the group should present at least one problem. So don't just let one person do all the work. Everyone help each other so that every person in the group can present. Okay, before we get started, I want to actually look at this, look at the homework and talk about a couple of things first. So if you'll pull up the homework, bookwork. And the first thing I want to do is talk about starting with number 7. I just want to talk about something that we didn't really discuss. Matt, did you discuss intervals of increase and decrease and domain and range in the notes?
No, not in the notes. No.
Okay, so I'm thinking maybe not do that because it's not.
We did that before though, didn't we? I thought increase and decrease.
We did. Okay, so we'll do it, and then just because it is important. It's just that we have talked about it before, and we'll spend more time on it in the future as well. So it's not as important in this section. But so let's talk about it right here on number 7. If the parabola is going upward, you know that the sign of the leading coefficient is always positive. The vertex, you know how to identify the vertex. The axis of symmetry, the equation for the axis of symmetry, and we talk about the axis of symmetry, it always cuts the parabola right in half through the vertex. And the equation of the axis of symmetry, and again, this is going to be more important later on, is always going to be x equals whatever the x coordinate of the vertex is. Okay, so I'm going to let y'all work on this in a minute, but if you can identify the vertex, then you can write the equation of the axis of symmetry. Intervals of increase and decrease. If you look at the axis of symmetry, it's going to split between those. So in this case, it's going to be decreasing from -infinity to that x coordinate of the vertex, and it's going to be increasing from the x coordinate of the vertex to +infinity. Domain and range. Domain for all parabolas no matter what is always going to be -infinity to infinity, or for all quadratic parabolas. And the range will either be the y coordinate of the vertex to +infinity, or it will be negative infinity to the y coordinate of the vertex, depending on if the parabola opens up or down. So if it opens up, it's going to be this one. And if it opens downward, it's going to be that one. Okay, so before we get started, let's scooch down here. And the first thing I want to do on all of these is identify A, B, and C. So on 51, what is A?
Two.
And what is B? And what is C?
-4 and 1. Is my microphone working?
Anyone?
A little quiet, Timothy. He said it was 2, 4, and 1. Or
2, -4, and 1, right. 2, -4, and 1.
Sorry.
So it's worth it to write that down because you'll be using it. All right, on 53, what is A, what is B, and what is C?
½
Mm-hmm.
for A,
Mm-hmm.
0 for B,
Good.
and 10 for C.
Great. Okay. Now this one is not in the right order, so I would write it in the right order first. And then identify A, B, and C. If you don't recognize that it's out of order, that's going to mess you up. So make sure you put it in the right order from using decreasing, starting with a large exponent, working your way down. Okay, and 61 is in the right order. So A is 3, B is -4, C is 2. But what about 67? What is A in 67? And what should we do first on 67?
Got it.
Michael, what would you do first on 67?
I'm a little confused here. It says find the maximum Y value on the graph.
Okay, so
of-
we're not actually doing that yet, Michael.
Oh, because
All I'm wanting you to do is tell me what A, B, and C is.
Oh, okay. A is -1 and B is 5 and C is 0.
Perfect. Okay, because once you do that, everything else is going to kind of fall into place. Plus 5x. So A in this case is -1, and B is 5, and C is 0. And then on 75, what would A, B, and C be? Oops, I've skipped 73. On 73, what's A, B, and C?
A is 1/4, B is 0, and C is 0.
Right. Thank you. That's 74. Okay, what about 75? Hunter, do you?
Yeah. -1,
Uh-huh.
0, and 1.
Right. So A is -1, B is 0, and C is 1. Okay, then when you get to 83, 85, and 91, you don't really have to worry about A, B, and C because they're already in vertex form. So all you have to do is write the vertex and graph. And on 85, I don't like that 23. So if y'all will change that, just make it a 3. Otherwise, it's going to be so skinny you can't. It's not going to be very pretty at all. So just change that on 85 to a 3. Okay. All right. So we're going to separate into groups, put y'all in 3 groups, and we'll bop in and out checking on y'all. If you don't know your problems, the problems that I assigned, let me go back to that. These are the assignments, and I will remind you, I'll put it in the comments. So if you're not sure which ones, you really need to do all of them, but I want you to do those first. Then if you finish those before we reconvene back into class, then you can start the other ones.
Oh.
Number 3. Problem are you supposed to do?
It's a group 3, so we're 73, 75, 83, 85, and 91. So what numbers did you do for 73? Just picky with your numbers, you can do it maybe a little easier. I did 1, 2, 3, and 4, but you could definitely make your life easier by doing perfect quarters.
I think 2 and 4 would work pretty good. We did 2 and 4, and 4 and 16. This is taking too long. Where's the text? There it is. What does the quarter do?
You would multiply the y value by 1/4, right?
Yeah, that's it. To 0. 4 times a quarter is 1.
Yeah, 1.
16 divided by 4 is
4.
Should we just move this up? Just move it up. Is that what happens? August, Gabby, are y'all all right? Are you good in this?
Yes.
Did you say what's due with 75?
Not really, but the main thing would be flipping it to the correct order.
Yeah, it would help. I guess it's f of x. I should do f of x. F of x is equal to. You lead with the other term. It's what, minus x squared. That's horrible. Minus x squared plus 1. That's barely legible. Bring it on over. Not that one. This one. So I guess the thing to be careful on with this thing. Come on, number 1. Is probably the sign on your coefficients, right? The minus is on the x squared and the plus 1's on the 1. So these, I don't know how she does them, but like, if there wasn't a scaling factor on there, I would just draw the parabola, like 1, 1, 2, 4. I wouldn't even do a table personally. So how would you describe this thing?
We would have an inverse parabola, and then we would move it up 1 unit on the y-axis.
Yep. And so your vertex is like here. We go 1, 1. We're like right in here. We go 2, 1, 2, 3, 4. So it'd be at minus 3. Oh man, how good am I going to draw this with my little pad here? Whew. Oh. Ta-da. Trying to do that on the laptop pad is not the easiest thing. $83. So how do we think about 83? Is it inverted? Is it right side up? Is it scaled, stretched, shrunk? How do you know? What tells you?
Sorry, still writing out stuff for the previous one, but 83 you said?
Yeah.
It is scale is shift, right?
Oh, I was saying, is it scaled? Is it shrunk? Is it stretched? Is it flipped?
None of those. It's just shifted.
Yeah, it's just shifted left and right, up and down. So this is just one. So it's just a normal parabola. You could even think about that as like in vertex form. So where's the vertex of this thing? You could probably, hopefully, you can get it off of this thing, right?
Yeah, -2, 1.
Ooh, careful.
Oh, sorry, 2, 1. That's right.
2-1. Yep. 2-1 is right there, and it looks like a normal parabola. It is this. It's a 1 in front, so it's just a 1 scale. So we go 1-1. Woo. We go 2, 4. So we're up at what, 5 now? 1, 2, 3, 4. God, try to count these things. 4, 5. Right in there. Right in there. Woo. Try to draw this on a pad. You gotta make those noises there. It's important. Respondus doesn't pick it up, it's gonna claim it doesn't see your face. She at? What'd she do? Can I? Let's look at the breakout rooms. Does she have a time on this? Was she in breakout room too? You have what, 2 more?
Yes.
All right. You'll have them written down?
I've got them somewhere on here. On my phone, I think. I took a picture.
You want to write them down right quick? I was going to jump over to room 2, make sure they're getting treated.
Oh, you mean the solution?
No, just the problems. Just make sure.
Oh, yeah, no, I have a picture of the problems we're supposed to work on my phone.
All right.
Like the numbers.
So when you find the axis of symmetry, it's easier to find the decreasing and increasing f.
You been by here?
We're here, Mr. Sievers.
Yeah, we're
Oh, shit. Yeah, we're here, Mr. Sievers. So far, we're double checking our answers for 51 and 53. We found the vertexes for 51 and 53, but we're also finding the increasing and decreasing intervals.
I just put it into Desmos and it looks like you were right. It was increasing or decreasing from negative infinity to 10 and then increasing from 10 to positive infinity.
Okay, let me.
Awesome.
So yeah, did 51 and 53? You said you found the vertex.
Yes.
What's
For
the
51, the vertex was 1, -1. The equation, or
That's probably pretty good. If
Okay.
y'all do y'all understand where that's coming from?
how to get the vertex? Yes. It's getting a little tricky when we have an x and y value for increasing and decreasing. Olivia double checked on Desmos for 53 for the increasing and decreasing intervals, but real quick, how would you, since we have an x and y value, how would you write that as a decreasing and increasing variable? Because you got like two of them going on. Would you just
Okay. So for 51, what I'm thinking is I'm looking at this like the leading coefficient,
yeah,
and so it's positive. So what sort of picture are you thinking about?
like upward? Like
Upward parabola.
all positive, right?
Yes, it's a positive parabola we're thinking about. We know like this thing is happening at what, x equals 1.
Right.
So it's decreasing all along here. It's going down. So this all depends on how your parabola is flipped, because it'll be the exact opposite if it's like the other way. But this way, decreasing is going. Ooh, what is she doing? Ending this so soon?
So
Decreasing
real quick, go
from
ahead.
like minus infinity to what? 1.
Yes to 1, and then from 1 to positive infinity.
Yeah.
Okay, awesome. Thank you very much for helping, Mr. Supers.
And I should have
Excellent
some.
job today, guys.
I should have some brackets around this thing or some parentheses, but we didn't have enough time. Not enough time for parentheses. No.
There never is enough time.
Yeah.
I do appreciate your help, Mr. Supers.
Sure.
Real quick, Zahar, Michael, Olivia, is all this making sense?
Yeah,
Yeah.
I think that every time they come in and explain it again, it's like, yep.
It gets more
Excellent.
clear.
Yeah.
So,
Yeah, I got it. Thank you.
wait, did she just cancel the breakout?
Yeah, we're about to go back.
4,
Oh, we are?
3, 2, 1.
Okay, so I think everyone's back. So group 1, who I was just talking with, someone, and do it pretty quickly because we're going to run out of time here. Can someone tell me how to do number 7?
Okay, so since our vertex is 1, 0, we'll start off with A. Okay, so since it's a upward parabola, it's going to be positively.
Great.
And our vertex is 1, 0. And our axis of symmetry is going to go through the 1, so x equals 1.
Right, the axis of symmetry is always going to be x equals to whatever that x coordinate of the vertex is.
And our decrease is going to be negative infinity to 1. And the increase is 1 to negative infinity.
Right.
Going up.
So the decrease is always, you always when you're talking about increase and decrease, you're always talking about the X values. If you were to take this parabola and stretch it out, the ends would be pointing to negative infinity and to positive infinity, and it changed directions here at the number 1. So it's decreasing, going downward from negative infinity to 1, and it's increasing, going upward from 1 to infinity. And then finally, the domain and the range.
The domain is negative infinity to positive infinity.
Great, always. And the range?
0 to positive infinity.
Right. The domain is always going to be the X values from negative infinity to positive infinity. The range, if it's a minimum, you'll start at the Y value that's at the bottom and go to positive infinity. And if it's a maximum, you'll start from negative infinity and stop at whatever the Y value is. Okay, so who is in charge of number 9?
I am.
Okay, great, Bree.
So, for A, I got negative for the, yeah.
Right, because it's pointing downward.
It's facing down. Yes. For B, I got -3 and -2 for the vertex.
Yep.
C, the axis of symmetry, I got -3 for the X.
Yes, yep, it's always going to be X equals to whatever the X coordinate in the vertex is. Good.
For D, it's increasing negative infinity to -3.
Great.
It's decreasing -3 to infinity.
Beautiful.
And for E, the domain is negative infinity to infinity. And the range is negative infinity to -2.
Great. So the domain for all quadratic parabolas is going to be negative infinity to infinity. And the range, if it's going downward, it's going to go from negative infinity to the top Y value, which in this case is -2. Perfect. Okay, 21. Who's in charge of 21?
I guess I'll do it.
Aurora?
Yes.
Okay, thank you.
Vertex, our vertex is -1, 0.
Great.
Then our next point is 1, 1. So our leading coefficient is going to be 1.
Right, because so if you go over 1 and up 1, that tells you what your leading coefficient is going to be. So if you go over 1, up 1, that means the leading coefficient is going to be 1. And then what?
X equals 1.
Mm-hmm.
1, so it's negative.
Plus 0, right. And you don't have to write that plus 0. So we know that the vertex was -1, 0. So this is our H, this is our K. Our A, we can determine by from the vertex go over 1, and however much you go up to hit the next nice point on the parabola, that is your A. Okay, so number 23, Michael. Michael, did you do 23? Or who else was in that group?
Do that.
Monica?
Yeah.
Great.
So for the A, we got 2.
Yes, because if you go over 1 from the vertex, you go up 2. Right, exactly. So our A is 2. So what's the vertex?
The vertex, I think it was like -0. I think.
It's just 0, 0, right? 0 is not positive, nor is it negative. So it's just 0. So, okay, so I think I understand. You're trying to put it into the equation, right? So that's why you're saying, I get it, I gotcha. So you're gonna say Y equals 2 times X minus 0 squared plus 0.
Yes.
Yeah, and so you don't really have to worry about the zeros, right? You could leave it like that if you want, or you could just write 2X squared. Awesome. You did great. If you are having problems with any of those, please stay after class for a little bit, and I'll be glad to go back over them with you in more detail. Okay, so group 2, we're being asked to find the vertex and then find the intervals of increase and decrease. So can someone tell me how to do 51?
Sure thing. So 51, 2x squared minus 4x plus 1. Our a value is going to be 2. B value is going to be -4, and our C value is going to be 1.
And who is this talking to me?
Timothy?
Timothy, thank you.
Awesome. So when we write out the equation, well, not necessarily write out the equation, we can still solve for h. So if you just put -4 over 2 times 2, it'll come out to -4 over +4.
Mm-hmm.
And you should equal to -1.
Mm-hmm.
And we'll -1 back into the general form. So
Good.
2 -1 squared plus -4.
Okay.
1. Good.
Right, you got it.
Is that,
Yeah,
is that
okay.
correct? It should be
Say again?
-b over 2a.
Right.
Right. I'm sorry. Yeah. So it should be +1.
There we go.
I wrote the formula wrong.
That's okay. Thanks for catching that. All right, so
Thanks,
that's going to
Steve. So
be
it should be 1. Scratch out the positives. So it should be 2 times 1 equals 2 squared. 2 plus, I'm sorry, 2 minus 4, 1. Okay.
So that would be -1.
-1. So our
Okay.
vertex would be, so we have h, which is 1, and then we have our k, which is -1. So our vertex is going to be 1, -1.
Okay, and so what's the vertex formula?
I'm sorry, yeah, so vertex formula. So it's going to be, you mentioned that we don't really have to use the a value anymore, but so did we?
Well, you have to use the a, but it's just the same a as the original problem.
Right. So it should be 2.
2,
Right. X minus 1 squared minus 1.
Beautiful, right. So what's so nice about when you're putting it in vertex form, the a in the original problem just is the same as the a in the vertex form. So once you find the vertex, you've basically found the vertex form of the problem.
Right.
All right, 53.
Well, real quick, Ms. Watson,
Yeah.
what about the increasing and decreasing intervals?
Oh, thank you. Yes. So what's it
Okay.
so first of all, is this parabola opening up, going upward or going downward?
It's going up.
Yeah.
So it should be positive infinity. I'm sorry, negative infinity. 1 to negative infinity, and then negative infinity to +1.
So it's negative infinity to +1 is going to be the decrease, right?
Right.
And then the increase is going to be what?
1 to positive infinity.
Right, 1 to infinity. Great. Okay. Great, Timothy. That's awesome. All right, 53.
I can do 53.
Thank you. Is this Aurora?
It's Olivia.
Olivia, I'm sorry. Olivia. It's so hard to tell sometimes. Okay.
So to get the vertex, we have A is 1/2 and B is 0, and then C is 10. So we put in h equals 0 over 1/2, but it just became 0. So
yeah.
Then we plugged that back in, and we got k equals 1/2 times 0 squared plus 10, and then we just got 10.
Great.
And so the vertex was 0, 10, and then in vertex form, I got y equals 1/2 x minus 0 squared plus 10.
Great. And if you want to, you could just write that 1/2 x squared plus 10, but either way is fine.
Okay.
And then, so what's the increase and decrease?
We got 10 to infinity.
Okay, so yeah, so this thing is opening going upward, right?
Mm-hmm.
Right. So it's increasing from 10 to infinity.
Yeah, that's what we got.
And then what's decrease?
We got the decrease was negative infinity to 10.
Beautiful.
Ooh, careful.
But now that I'm looking at it, it seems wrong.
Yeah,
Why?
it should be your x coordinate there. Should be just
Oh,
0.
you're right. You're right. We're doing the increase and decrease is always determined by the x
Yeah,
values.
if they asked you for the range would be from like 10
Right.
off to
Oh,
infinity.
yeah.
Right. Right. So
actually-
it should be. Thanks for
Oh,
catching
so
that.
Well, no,
So it's
actually,
yeah.
that was my fault. Like when we were going over it.
Oh,
It's
it
no
should be
one's
the
fault.
0 in the decrease.
So yeah, sorry about that, Olivia.
No,
Yeah,
you're
wrong
good.
information.
That's a very common mistake. So I'm always glad when we do these kinds of things, because that's what people do all the time. So just and I didn't even catch it. I'm glad that Matt caught it. So the increase and decrease is always determined by the x values.
So it should be, the increase should be 0 to infinity
Right.
and negative infinity to 0.
Yes. Thanks.
Okay.
Right. Okay. So now we're on number 61. Who did 61?
Oh wait, Ms. Watson, we missed 57.
Oh, yeah. Okay, 57. Who did 57?
Well, honestly, our group didn't get to 57, but I'll go.
Okay.
I mean, I did it. I
Oh wait,
got the
Matt?
vertex was -1 and 7.5.
Okay, so the vertex, is this Michael?
Yes.
Okay, hold on. Let me write this down. 57. So so we said A is -6, B is -12, and C is 1.5, right?
Yes.
So the H coordinate would be what? How did you find?
-1.
Okay, so the H is 12 over 2 times -6, which is -1, yes. And then what's K?
I got 7.5.
So K, we're going to plug that -1 back in to the original problem. So that would be -6 times -1 squared minus 12 times -1 plus 1.5.
Yeah.
So that would be -6 plus 12 plus 1.5, which is 7.5. Is that what you said?
Yes.
Okay, perfect. Thanks. So the
Okay,
vertex
I'm gonna-
is
Sorry.
-1, 7.5. So what's the vertex form?
Okay, so what I put was y equals -6, x plus 1 squared plus 7.5.
Right. So the A is the same as in the original problem. So it'd be -6 times x plus 1 squared plus 7.5. Nice, Michael. Okay, so what is your intervals of increase and decrease?
Okay, so the increase, well, this one's backwards. So the increase is going to be, let's see here, -infinity to -1.
Yep.
I believe. Yeah, that's increasing. And then the decreasing is -1 to infinity. Or no, -1 to -infinity.
Right. No, you
forgot.
were right the first time.
Well, because if it's going back down again, that's
Okay,
gonna
so-
go
and
back
that's
down to
another-
-infinity again.
Nope, because okay, so that's another thing people think, but remember that that when we're talking about the decrease, if you took this and stretched it out like a rubber band, the negative infinity would go to -1, and then the negative infinity to positive infinity. Do you see that? Would
Okay,
be-
so because it continues to move along the x-axis
That's
slightly,
right.
it's positive infinity. Okay,
That's right. We're talking
so actually
about
I
X,
was right. Okay,
yeah, we're talking about x values.
yeah, I'm
And
getting them.
so the x
axes
values are
mixed
getting
up.
bigger and
Yeah.
bigger, right?
In any case.
Right.
So -1
Exactly.
infinity.
And that does confuse people as well. All right, so now we're on 61. And all it asked on 61 was to find the minimum y value. That was all it asked. So who did 61? Anyone?
Let's see. I started on it. But these instructions are different. It says find the minimum Y value.
So that's all they're asking is the minimum Y value.
Right.
So how would you find the minimum Y value?
Oh, wait, because this is a positive parabola.
Right.
Yeah, so the minimum is basically all we have to do is just find the vertex.
That's right. The Y coordinate of the vertex
Let's
is what
see
they're asking
here.
for.
Let me do that real quick.
Okay, I know, guys, that we're past time.
2 over
Right on
3.
time. So if you need to leave, I understand. If you want to hang on, we'll finish this and I will post these all.
Yeah, I was a little late in hitting the record, but I'll definitely catch all this. So.
And I'll just post all of this as well. So let's go ahead and finish these out. For those of you that can stay, that would be great.
Can I ask a question here?
So
like on 61, I'm trying to work out the H value and I'm getting 2 over 3.
Okay, so
But
let's
when
say
we start to plot this, do I convert this to a decimal or something or what? Like,
you can if you want to, just as
'Cause, I
long as
mean,
it's an exact value. So opposite of B is 4 over 2A. So that would be 4 over 6, right? I just leave it 2/3.
so 2/3 can be a point on a graph or one of the axes at least?
Yeah, we probably won't give you one that's 2/3 because they're hard to graph, but
Yeah,
it for sure can happen.
I'm just thinking what looks better in terms of like when we put it in our notation.
Yeah.
Yeah. So anyways, let me just get the next, let me get K here real quick.
Yeah.
Well, actually, no, I'm gonna need a calculator. So
yeah, so if you find K, it's gonna be 3 times 2/3 squared minus 4 times 2/3 plus 2.
Yeah.
And that turns out to be 2/3 as well. So that would be the minimum value right there. The minimum is always the minimum or the maximum. Whenever they talk about min or max, the actual minimum or max is always going to be the Y value. Okay, so I'm going to go, because we're over time, I'm just going to go ahead and go through these. On 67, the maximum value, because the leading coefficient is negative on 67, the parabola will open going downward. So the H value is the opposite of B over 2A, which is 5/2. And the K value, if we plug 5/2 into that equation, we get 6 1/4, which is the same thing as 25/4. And we're not going to give you ones like this on a test. So don't worry about that. But I mean, they definitely can happen. So on 67, the maximum value would be 25/4. All right, on 73, the vertex is going to be 0, 0. And the A value is 1/4. That means you would go over 1 and up 1/4 of a unit. It's going to be a fat parabola from the vertex. On 75, this is the same thing as negative x squared plus 1. So the vertex would be 0, 1. We know it's going to be pointing downward because the leading coefficient is negative 1. So this would tell us to go over 1 and down 1 from the vertex. So it would look like that. On 83, the vertex is 2, 1. This is vertex form. And the leading coefficient here is 1, even though it's not written. So from here, we would go over 1 and up 1 on both sides of the vertex. This one I told you just to do 3 because 23 makes it just way too skinny. So the vertex would be negative 1, 3. And then 3. So if we would go over 1 and up 1, we're going to go over 1 and up 3. Whatever this number is, that's going to be our points on either side of the parabola. So I went over 1, up 3. And it's going to be a very skinny parabola, but not as skinny if it had been 23. And finally, this one, f of x equals 2x squared plus 4x minus 2. So we have to find the vertex. So h is equal to the opposite of b over 2a. So in this problem, a is 2, b is 4, c is negative 2. So that would be the opposite of 4 over 2 times 2, which is negative 1. And then take that negative 1 and plug it back in. That's going to give me my k. And that's going to give me negative 4. So the vertex is negative 1, negative 4. And I know it's going to open going upward, and the leading coefficient is 2. So I'm going to go over 1 and up 2, over 1 and up 2 from the vertex. And that's my parabola. Okay, the last 4 problems. The height y of a stone, this is 109, thrown from ground level after x seconds. So if you start on the ground and you throw the stone up, it goes up, then it goes back down and hits the ground. So it would be D. Where this is the time in seconds, and this is the height in feet. So on 115, the height in feet of a golf ball after t seconds is given by this formula. So again, we have, this is the time in seconds, and this is the height in feet. So the ball is going to do like this. It says find the height of the ball after 4 seconds. So after 1, 2, 3, 4 seconds, we want to know how high is the ball. So we're going to plug in 4. So we will say h of 4 at 4 seconds is 96 times 4 minus 16 times 4 squared, which turns out to be 128 feet. So right here at 4 seconds, we are at 128 feet. That says, that's the maximum height. Oh, then it says, is the golf ball moving up or down after 4 seconds? So I'm gonna figure that out after I answer part B, find the maximum height of the golf ball. So the maximum height of the golf ball, first we'd have to find the time that it reaches the maximum height by saying T is equal to the opposite of B over 2A. So in this problem, A is negative 16 and B is 96. So that would be negative 96 over 2 times negative 16, which is 3 seconds. So that's, so at 4 seconds, the ball would be on the way down. So at 3 seconds, if we plug 3 into the problem, the height after 3 seconds would be 96 times 3 minus 16 times 3 squared. And that turns out to be 144 feet. At 4 seconds. Okay, then it says determine the domain and the range. Well, the domain is the x values, which is the time. So can you tell if this right here is 3 seconds is at the top, and this is 0, what would be, how many seconds would it be to reach the bottom? If 3 is halfway, then it would hit the ground at how many seconds?
Should be 6 then, yes?
Yeah, 6 seconds, right. So at 6 seconds, the ball hits the ground and is at 0 feet. So the domain, which is the time, is going to be from 0 seconds to 6 seconds, right? What's the range of this problem? Is it seconds or feet? The range is talking about the height, right, of the ball. What's the lowest height that the ball is ever at?
0 feet.
Uh-huh. And what's the highest height the ball is ever at?
According to B, that would be 144
Yes.
feet.
So that's the range. So when we're talking about domain and these problems, we're talking about the time of the curve, and it's from 0 to 6 seconds in this case, and the range is from 0, the bottom of the graph to the top of the graph. The height would be from 0 to 144 feet. So on 119, it says, suppose the revenue in thousands of dollars that a company receives from producing X thousand DVD players is given by R of X equals X times 40 minus 2X. So I'm going to go ahead and multiply that out. So that would be R of X equals to 40X minus 2X squared. So I know it's going to open going downward because the leading coefficient is -2. A is -2 and B is 40. Okay, evaluate R of 2. So if we put 2 in here, change color. R of 2 would be 40 times 2 minus 2 times 2 squared. And that would give us 72. And that's 72,000. So to interpret that, that would mean that R of 2 means that 2,000 DVDs were sold and that the revenue from that is 72,000. And it says, how many DVD players should the company produce to maximize its revenue? So we're talking about the top of the parabola and we want the maximum revenue, but it says how many DVD players. So we're looking for the X value because this is the number of DVD players, comma, then the revenue from what it makes. So we're going to say H equals to the opposite of B over 2A. And that would give us 10. So the answer to B would be 10,000 DVDs. Would maximize the revenue. And then we need to know what is the maximum revenue. So we're going to take that 72 and plug it back in. And that'll tell us what the maximum revenue is. What did I do wrong here? The revenue is 72. Oh, it's 10. I'm looking at the wrong part of the problem, y'all. Sorry about that. We're doing 10, right? Not 72. And that gives us 200. So that means that the revenue is $200,000 when 10,000 DVDs are sold. Okay, finally, this last one. And I know that in this one, if you look at this, you can tell what the vertex is going to be by the, when the y's start repeating, like right here, this goes 5, -1, -3, and then it goes back to -1 and back to 5. So the vertex is going to be 1, -3. So I know the equation is going to be y equals to sum a times x minus h squared plus k. So that's going to be a times x minus 1 squared minus 3. Now in this class on a test, your a will always either be 1 or -1. In this problem, that's not true. But in any testing material that you'll see, your a, this a will either be +1 or -1. So all you have to do is be able to say, is this parabola opening upward or is it going downward? And in this case, what's happening with this parabola? Is it opening upward or downward? And you can plot points to see it if you want to, or you can just look at it and tell. Is this parabola opening going upward or is it opening going downward?
Well, I mean, if the A is positive, then I'd say it's going upward.
Well, that doesn't have to be positive though. It could be positive or -1.
So like, for example, if we're going off of the coordinates of 1 and -3, then the A at that point, and then these are the different points in the graph, right?
Yep. So like
Okay, so it's like
-3 would be here. -1, 0.
Right. Yeah, so you know what? I think this is going up because if you look at the y coordinates, they're trending upwards. Yeah.
Right. Right. So it's going to be going upward. So you would just have to say that A is 1. You just have to know it's positive.
Okay.
But in this particular problem, I just want to finish it out correctly. We don't know what A is, and we don't know if it's 1 or -1 because this problem is a little bit more complicated than what you'll see on the test, but we can figure it out pretty easily. And I think some of y'all would have absolutely no problem with this at all. So we know that this is the equation. We just need to figure out what A is. So I can pick any other point but the vertex. So I am going to pick the point, I don't know, this one right here. I don't care which one you pick. And I'm going to say 5 equals to A times -1 minus 1 squared minus 3. So I'm just plugging that point back in. And that would give me 5 equals 4A minus 3. And then I'd add 3 to both sides and I get 4A equals 8. And that would give me A equals to +2. So in this particular problem, your A is +2, but you're not going to have to do that. All you're going to have to do is determine whether A is +1 or -1 in the problems that you're going to be seeing. Okay, I know we're way over. Sorry about that. And if you